All right, so we are starting our first section of the year, 1.1 functions, okay? This should feel like a review, got it? Nothing I go through here, except maybe one thing, should be brand spanking new, got it? But the concepts and everything else should be a review, okay? So here we go. Our first objective is to determine whether a relation represents a function, okay? So keep that in mind. We know that all functions are relations, but are all relations functions? No, they're not. So let's identify. Why is that? Well, that's because we have a relation is a correspondence between two sets, okay? So I'm comparing two things. That's what makes it a relation, okay? When we say correspondence, we're saying that y depends on x, okay? And so we write it as x corresponds to y, okay? So x happens first, and then y happens next, second. Got it? All right, so this right here is a relation. We know that for sure. Okay. So when we look at this as a relation, this equation is a relation. These ordered pairs are a relation because there's more than one way to represent a relation. Okay. Next, we're going to look at a mapping. Okay. Mappings are from Algebra 1. A mapping is another visual way to look at a relation. So this mapping represents the states and the number of representatives in Congress. Number of representatives in Congress. So when I look at this, Alaska has how many representatives? Seven. Arizona has? 8. California has? 53. Colorado has? 7. Florida has? 5. And North Dakota has? 4. This relation is also a function. Why is this relation a function? My input, right? My input only maps out to one output. Yeah. Make sense? So it is a yes for being a function. Okay. Now, I can write it as ordered pairs even if it's not a function. But if I wanted to write it as an ordered pair, I just need to make sure I understand what's my domain, which means my x, right? Mm-hmm. And what's my range, which means my y. So what would my ordered pair be? What's the first ordered pair? Alaska 7. Alaska 7. Okay, just get that? Yep. So if I click that, just go, okay. Whoa. You want to dwell? No, you don't have to, unless you want to. Okay. All right. So I would say Alaska 7, Arizona 8, California 53, Colorado 7, Florida 25, North Dakota 1. It's just another way to represent the relation. Make sense? Okay. Notice also when I wrote it in ordered pair, I use braces. Okay. Braces symbol that this is a set, that this data came from the same information. Make sense? Mm-hmm. Okay. So we use braces. All right. For the longest, I called them mathematical squiggly lines because for some reason I could not remember what they were called. And then one day I was like, oh, a brace. All right. So here we go. The function does not have multiple outputs. Okay. So looking really quick, if I'm comparing persons to phone number, is that a function? Why is it not? Who ruins it for us? Colleen. Colleen got 2 phones. Okay. All right. What about animals and their life expectancy? Yes, this is a function. Okay. All right. We're going to quickly kind of just do a quick check for examples 2 through 5. Okay. All right. Here we go. We're going to just make sure that in order for it to be a function, what's going to have to happen? It's just going to be exactly one element in the range that corresponds to the domain. Got it? You make it sound like I just read the definition. Okay. All right, really quick. Level of education and unemployment. Is it a function? Yes. What represents my domain? The education. What represents my range? Unemployment. Easy enough?
Yes.
All right, let's do another one. Is this a function?
Yes.
What represents my domain? What represents my range? Good.
Yep.
Here we go. Is this a function between carrots and the price?
No.
No, what this is saying, one jeweler tells it, no, that's like diamond carrots.
Oh. I thought it was like-
Yeah, yeah, no, it's diamond carrots.
Okay, I don't think carrots to me that much.
Yeah, like, yeah, $3,000, what kind of carrots are you eating? Is, okay, is this a function?
No.
No, why is it not a function?
Ruined it.
This right here, this 86/100th of a carat. Two different jewelry places are selling it at two different prices. Okay, so it's not a function. All right, any questions about identifying from a mapping? All right, we're gonna test your skills from ordered pairs. Okay, when I'm looking at the ordered pairs, what am I looking at?
X's.
I'm looking at my X values. So A, is it a function?
No.
Why is it not?
Twos.
The twos, the twos, the twos, the twos. Pew, pew. All right. Nope. It tells you when to write. It says we're just quickly checking it. You're writing yes or no. All right, here we go. B.
Yes.
And that's because what?
X's.
All the X's are different. Doesn't matter if anything else. Yeah. Repeat all the Y's you want. Okay. All right. Our last one. Why is it not?
Oh.
The fours. Pew, pew. So therefore it's not a function. All right. Any questions? Easy enough?
Tyler.
Okay. Let's look at it from an equation perspective. Okay. This is called an equation. Why is it called? Shh. This is called an equation because there is an equal sign. Equal sign is what makes it an equation. Got it? Without it being an equal sign, it is not an equation. It's an expression. Okay? Expression. I don't know what I just said. So we have y equals -1/2 x minus 3. Is this a function? Yes. Well, we know it's a function. And what kind of function is it actually? It's a linear function. Okay. Now we know that. But if I was brand new learning this, how would you tell me that this is a function? Why would you tell me this is a function? How do I know the x's don't repeat? No, the being fraction has nothing to do with it. If you had to explain to someone who didn't know what a linear function was, that this is a function, what would you tell them?
I don't know. I don't remember this.
All right, yes. And what you would tell them is that because if you multiply a number by -1/2 and subtract 3, you're gonna only get one solution. Does that make sense?
Yeah.
Okay, now if on Monday I did this and I got one answer, then on Thursday I did it and I got a different answer, I did my math wrong on one of those days, or I did my math wrong on both of those days, right? But I'm only gonna get one solution if I plug in a value. Does that make sense? That would be your justification as to why this is a function, not just because, oh, I know that. Okay. All right, let's talk about this one. Is this a function?
No.
We got to know. I can produce two y's, right? Now, reason being, before I identify whether it's a function, I want to get the equation where y is by itself. So the first thing I'm going to do is solve for y. So step 1 on example 7, we do what? What did we just say? We solve for y. Okay. What do I need to do to solve for y? I'm going to subtract 1. Got it? And then what? And then I'm going to take the square root of both sides. So the second thing I did was subtract 1. The third thing I'm going to do is I take the square root. And what I do to one side, I do to the other. What happens when you take the square root of something? You get a plus or minus. It produces two outputs, right? So this means I have two outputs. And if I'm a function, can I have two outputs? No. So this is why it's not a function. Okay? It's not a function because when I get y by itself, I'm gonna have more than one output. Okay? I should have written it a little more to the left. Right. All right. Questions about example 7. Questions about our first part of this lesson? No? Awesome.